Okay, so in this video, oh, by the way, it's May 8th, 2025, and this is a Project Blue update uh, where we've moved to uh, the 800 by 600 16-bit desktop from the 640 by 480. So we'll get to see that. We're using DMA and PSRAM. We'll also get to see that. There's two types of styling for Windows and so on. Type A and Type B. We'll demonstrate that, and we'll talk about 3D animation and gaming potential, um, with some showings for that as well. Okay, let's move forward. Okay, so for this segment, I just want to show you the minimal, and it's very slow and fast, very slow progress that's being made here because of I tried to use IDF. My code was being deleted and backups and everything. Things are being sabotaged, so I have no idea. But for Arduino, I've developed two types of desktops, and I'm not sure which one I am going to go with for Project Blue. So I'd like your feedback on that. Do you guys want Type A or Type B? So I'll show you Type A. I've loaded it in the board right now, and it's fully 800 by 600. We'll go into full screen. Um, and what's the difference? So you can see we have the movable windows again, but this time you can move the windows uh, from four different uh, four different sides. So, for example, you can resize it from here, you can resize it from here, you can resize it, blah blah blah, and so on and so forth. Before, in the other style, like style B, you can only do it from one point. Um, So we'll delete. Oh, actually, put this select fruits here. Just move things around. Sorry, just give me a moment. And we have some more controls. So the funny thing is, with moving from 640 by 480, you can immediately see that, and I'll make the buttons resizable too, but for now I don't want it to be. Um, you can immediately see that we have more space to work with. So we literally have more space to work with. And actually, you know what? I'll move this here, and I'll move this here. So I just move things around in the blue desktop. Delete here. Put this here. I'm using the trackpad, so it's hard to get. I should be using a mouse. And the last time it was like super early in the morning, like 5:30. I didn't want to wake anybody, so I was whispering. So hopefully you guys can hear my voice now. And we'll maybe move these over here. Yeah, there's so much more room moving from 640 by 480 um, to 800 by 600. And let's say we want to select, let's go mango. So you've selected, you know, it highlights it and blah 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 and all those controls. But really, it's the appearance that still same functionality. We've just added that. So type subtext here, and that still works. Remove date. That remove this. Right. Um, make this taller. Make this wider from this side. What about from here? What about from here? And from here. So everything does work. And put this here. Um, yeah, so this is it's just the styles, right? So does this control work? Yeah, it does. Turn it off, turn it on. Remember the EO radio button and the checkbox from like BB6 style. Still used in Windows these days. Um, but yeah, so this is the idea. this is the idea. Let's type project blue is moving. So it's wrapped off there, but we want to, we're still able to do that. So yeah, so now your desktop's 800 by 600. We're not going to 1024 by 768. It's too much, and we're definitely not doing 24 bits. Too much. It's overkill. Um, but what if you resize this? Yeah. So we still have a cursor and we can move it. Now the cursor is not, sorry, the scroll bar. It's not mapped to the arrow keys, but it does work. I just want to show you guys that little things. Um, so that's type A with these little squares on windows and things that can be resized. Fig. Let's remove fig. Type some text here. Remove that. Yeah. So yeah. So that's what we've done so far. I hope you guys enjoyed that. And now you know what type A looks like. So we're just going to move on to type B. Get out of full screen mode. Oh man, 800 by 600 is really good. I set it to 5 frames per second, but we can do, like I said, up to 20 frames per second. 20, 25. But do we really need that? No, we don't. Maybe 15 frames would be sufficient. So there'll be a setting in the desktop lets you set your FPS. Um,
Okay, so we just showed you type A desktop. Now we're
okay,
gonna go
and
into type
we'll move on and
B,
we'll go to
and clearly you can see
type
the difference in how the windows and stuff are done. Let me just set a background here. Last video last clip I forgot to set a background. It's kind of boring with that one. Yeah, so again, uh, so now you just have this one little thing. So I personally I find type A annoying because I'm not used to that. But some people may like that style, that flexibility that it'll give to their user GUI environment or whatnot. Um, so it really depends on the individual. Uh, so again, this is you can clearly see like you know it's pink, right? It looks pink, but it should be red, and that's just an issue with setup. So I'll fix that obviously, and it's not going to be this gross these gross colors. Right now, it looks kind of VGA-ish. It doesn't really look 16-bit because it's haven't enabled that functionality. I'm just basically, but it is 800 by 600. Um, yeah, so yeah, it's let me move resize. Yeah. That's the that's the difference. Is just the way the UI looks, right? And that's we're flexible on that. We're definitely flexible on that. So, oh yeah, I forgot to make this movable, but it is resizable. Okay, so that's it for type B because we're not going to take too much time. It's you already know it's 800 by 600. You already know the basics of what it looks like. Um, that's really it for this part. We're using a background now, and it's really important, I think, when you have a GUI thing, to be able to select a background. If you're into that, I honestly cannot work without a background, some kind of background image. It's just not fun. But if you just like the gray, or whatever color bland, it helps you concentrate more. That's also fine. Um, But yeah, so here we are, and that's what it is. That's the end of this part. Oh, it looks like Yark. Jesus. Gotta change that font. Okay, let's add that. Yeah, that's it for this. And let's move on. So,
Okay, so in this next segment, what we're doing is, we in the last video we pushed the S3, um, to do, uh, let's see, what did I do? It was 1024 by 768 24-bit images. Now it was super slow. Um, but what we're trying to do now is move to from a 640 by 480 desktop uh, to 8 bits to an 800 by 600 desktop, 16 bits, which is a very significant change. And I'm just doing some preliminary tests. This is early work, and it's also uh, also experimental. So what I'll do now is I loaded the board with the experimental code, just for 800 by 600 resolution, 24 bits. Um, so right now we're doing the plasma, and we can go to full screen. So this is being generated by the S3 board in real time. It's being rendered in two frames. One frame is being updated while the other frame is being shot out over the network. And we're getting, you know, less than a frame a second, but that's okay. This is actually 800, like this is true native, no compression, 800 by 600, full depth 24-bit. It's generated, right? We use DMA through Arduino, indirect DMA, um, to do the copying to make it faster. But as you can see, this is generated in real time by the S3 board, the ESP32S3. It's incredible. It's incredible that we can do this and that we can indirectly access DMA from Arduino, and also use that 8-bit, sorry, the 8 meg RAM. So if you look at the statistics here, um, so this is how much total SRAM you have running on a CPU. So we don't have the 512K because of the IDF and the Arduino overhead. It's eating significantly into it. So we only have 3.5, and which is like, it's like less than a fraction of a meg, right? Less than a fraction of half a meg. So um, so free we have even less. That's total we have available for our Arduino sketch. We have like half of the 512K basically free. We have the full PSRAM, the 8 megs, and that's what makes this stuff possible, right? Because we're doing everything in the slow PSRAM. But what's really cool is from Arduino, you can access that full 8 megs, and this is how much we have free. This is how much we've allocated. This stuff is set in real time by every single frame and spit out to the console, so we always know, what's going on, especially if there's a crash or something. So this is experimental, but it's working. It's incredible. DMA, PSRAM, um, everything in real time is working. And what are we able to do other than like Plasma or whatever? How can we push this thing to the max before it starts crapping out? Um, well, let's do some 3D landscape generation, and we have a little routine here, and we're able to do that. So yeah, your FPS is only like say zero point zero 0.03, but remember this is 800 by 600, 24 bits rendered in real time with no hardware acceleration, right? No JPEG, no compression, no frame, like nothing, right? This is on the S3. This is a $5 board, right? Doing this in real time and streaming it to the network. So you can stream this over the internet. Your board could be sitting at home or at work, and you can access this from your phone at any time. So if you have a desktop, like I'm going to show you based on this, I mean, a lot of things becomes possible for this board other than consoling in and like reading temperature of your plant, right? Or turning a light on or streaming some music. I mean, there's just so much more you can do with a framework that allows you to access the board through a GUI in real time. Um, so another thing I can do, uh, well, there's a whole bunch of test patterns here, but I mean, we're not really interested in the test patterns. We're really interested in, you know, how far we can push this board. Now, you don't need 24 bits for your desktop, um, so we're not going to do that. But that we can do that. At least we know what the boundaries are, right? To do this sort of thing. So we know we can do 1024 by 648, 24 bit. Now we're doing 800 by 600, 24 bit, very easy. And our desktop will be 800 by 600, 16 bit, which will, give a nice headway for running apps and stuff like that. So, I mean, it's just, it's incredible um, what you can get off of this little piece of hardware for just a couple of bucks, right? It's truly incredible. So I'm gonna go give you like just some granularity here. Let's go rainbow noise, and you can see the data rate. It's less than half a meg, right? So look at this. Look at this grid. Like this is being put out by this generated all these pixels, right? 800 by 600 times 24 bits. That's a lot of pixels being generated in real time, right? And pumped out over the network, and then gets displayed by our browser, right? By any browser from anywhere. I mean, it's stunning. It, the the amount of control that you have, I mean, what I'm trying to show is that if you really push this thing and you know what the boundaries are, then you have a better idea of, how we can make the apps, the desktop better, and how we can make the apps. So now we have indirect access to DMA, we have full access to PSRAM for this image that's being generated in real time. Um, we're using, let's take a quick look. We're allocating about, yeah, 2.8 megs. So yeah, 2.8 megs. That's not too bad. Now we're not using all of it, right? We're not using all of it. We're just allocating it. But that we have dynamic access in a running program to PSRAM to change it on the fly from the CPU core. I mean, we're 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 really testing the boundaries of Arduino because IDF is really where you want to do it. And the problem with IDF is anytime I do anything in IDF, my code disappears from my computer. Um, I cannot explain it. I have things working with IDF because IDF is the way to go. Uh, but my code just disappears, and then my environment gets sabotaged and things break and it never works. So like there's missing files, files have errors, like not my files, but the libraries that are shipped from the manufacturer, which makes no sense. So I can't use IDF, which is unfortunate because then I could explore I could tap into you know, um, the full breadth of the hardware, and that's really the way to go using the manufacturer's tool. But then, like I said, if I do that, um, my code disappears off my computer and on my backups, and I could never get it again. So I've lost so much time and effort trying to use IDF, which is a really good tool, by the way. It's very sad that I can. So I'm stuck with Arduino and I'm pushing the maximum of that, and there's only so much you can do. But I'm not complaining here. I'm just moving forward, and just kind of show you, you know, what we're able to do at this point for exploring the boundaries for making Project Blue come to life and giving it legs and stuff like that. I mean, this is just stunning. This is 800 by 600. I showed you this in 1024, 24 bits, but I mean, you can see it updating faster, obviously, in 1024 by, sorry, in 800 by 600 at 24 bits. But that 24 bits, it's incredible. It's an incredible mode that, you know, we're able to do that and pipe it through the network and actually view it. It's a little sad that I can't accelerate it, but there's just not enough SRAM. There's not. You need to do computation, and at half a meg, like a quarter of meg, it's not enough. The S3 is just it's not enough. So, um, but for whatever it has, we'll kind of max it out. Try to put everything in slow PSRAM and then use SRAM for just calculations and real time stuff. So, well, that's it. This is the end of this segment, and hopefully you enjoyed that. And it just shows you, like, you know, where Project Blue is going and what are the boundaries that we're working in. So I hope you like that. And let's move on to the next piece.
Okay, so now what we're gonna do is look at something other than desktop. Like, say, for example, you want to do games, so you want to know, like, what are the boundaries, like, what can you stretch it to, right? So I've set up the board as an AP, and I'm going to connect to it right now because I find that if you're trying to do what I'm trying to do right now, through just a basic network, it's very laggy and my network sucks. So I connect directly to the board, and yeah. So if you want to do games eventually, no, I'm not sure why you want to do games on ESP32, but let's say you want to do some basic gaming just for kicks or whatever. You want to know, like, what are the boundaries of the software rendering that you can get, right? So I'm trying to, like, play with that right now because I want to be able to in Project Blue. So anyways, right here we have a counterclockwise rotating spiral on a rotating spiral that's multicolored, uh, and so on and so forth. And this is 16 bits. So this is not 24 bits, it's not 8 bits, it's 16 bits. It's I'm connecting directly to the S3 board. Uh, and it's like about 60 centimeters from my laptop. Um, so I'm getting decent frame rates, like 14 frames per second. The board is actually putting out. Let's see. Oh, I didn't put that stat in there, but the board is putting out about 20 frames per second, 20, 25. But because of the network, um, it's dipped down. But if you use ESP now, like if you want to get funky and do some weird shit, you can do ESP now. You might get faster. Um, you might get faster bit rate. And remember, because your GUI, your desktop and stuff now is broadcasting, you can do multicast, right? So let's say a scenario where you want to do multiplayer games, right? And you have one guy in Hong Kong, you have another guy in Mexico, and you have a girl in, uh, I don't know, Dubai or India, or let's give a shout out to Russia. Um, then those three individuals, because of the multicasting nature, obviously not ESP now, but through the internet, can actually coordinate and do that. So it's not just text-based apps and stuff like chatting apps that you can make, or but you can make like 3D interactive stuff, right? Um, and I'm just trying to show you like how this can be just for like a $5 board. It's pretty incredible. So if you're doing games, you care about animation and you care about colors, like color depth and stuff, right? And let's just disconnect here. And let's see what happened here. Oh, board's still up, super stable. It's just my network. So I'll just connect back. See, are we connected? No, I'm not connected to the board. I lost my connection. Shenanigans again. Okay. And sorry, it's a connectivity issue. It's always a connectivity issue. It's never really a board issue. Um, and so basically, that's really what you would want, and it allows you to do a lot of things. It really allows you to do a lot of things. I'm just going to reset the board just in case that might be it, but I'm pretty sure that's not it. So we're going to drop that connection there. When it resets, and we're going to go back. We're going to disconnect. We're going to reconnect. Yeah, it gives you that full functionality, and it's quite amazing what you can do with this board. Um, so this is just one pattern generation. Obviously, it's it's really up to you, right? Whoever is writing the game, or whoever is writing the app, or whoever is writing whatever. It could be a window or something. But I'm just trying to show you like what it's capable of. So right now, that's the end of just that little blip. I'm gonna pause the video now. I'm gonna load something else that I want to show you, and we'll take it from there. Okay, so you remember um, the Amiga ball, right? So now we have the S3 ball. So the S3 is able to replicate it. Now I know that used to be bouncing and stuff, and we can still do that. But you have to understand the Amiga had like hardware acceleration, right? So it had a dedicated hardware for doing sprites and pixels and images and audio and stuff like that. This S3 is literally doing this in it's doing this all in software. So it's doing it all in software. There's no dedicated accelerated nothing. It just doesn't have it. Now, I wanted to use SMD, like some of the vector processing capabilities to accelerate all this stuff so that it'll be a little bit faster. Maybe you can get an additional 5 to 10 frames per second additional. Um, but I'm not able to do that from Arduino. And again, I can't do IDF. My IDF stuff gets deleted and sabotaged. So for whatever reason, so I'm not able to do that. But I just want to show, let's say you wanted to make an app for the desktop for Project Blue, and you wanted to. This is 16 bits, by the way. Let's say you wanted to make a game, a chess game, but it's a kung fu chess game. And in the Kung Fu chess game, every time you move a piece, it does like these animated Kung Fu moves on the other guy if you're taking a piece off the board, right? And it remembers all the settings and all the history and everything, so that if you have a friend in India and you have a couple of friends, say in China or America, Canada, wherever, um, and they're all like you're multicasting, so a whole bunch of people is watching this from their device, and you're playing, I don't know, Bob is playing Harold, or I don't know, and the character does the kung fu moves and all that. It's all being done by the board, right? And this $5 board, and it's just incredible. But that's what a streaming desktop, and the apps for that opens up that kind of possibility. Because, like, can you, let me just ask you a question right now, right? Can you do that uh, with your just an Arduino sketch? Sure you can. Sure you can. But would it be fun, right? Will it be, it could be, it might be, but it would be very difficult. But with Project Blue, you'll be able to make apps and games and things like that, for multiplayer, multi-individual, for casting, for all that stuff from the board, right? So you can run it off of a battery, and it's just incredible. Like, what you can do for pets, what you can do for plants, what you can do for alerts, right? You can send text messages, to remind you, like reminder apps and stuff, but from the board, right? Now I know we already have all that with Google and stuff, but they data mine you. But your S3 board is not going to be data mining you, or at least we hope not, right? So that's the beauty of it, and it's just the whole fun of building something, uh, that doesn't take a lot of programming skills. That doesn't take any programming skills, and that is not very hard, and it's a very quick turnaround. So like you click a timer button, and you drag some functions into there, like, uh, like, instead of like typing code for a blink button, you just grab the blink function, and you tell it the delay and stuff, and that's it, right? In like plain English. So it just opens up a lot more possibilities, and then you can stack stuff on top of each other. But going back to like the Kung Fu game, that's the kind of thing you want, and you want now the board. You want to know the boundaries of the board, like what it can do, right? So even its software rendering. So if I had access to IDF and I could do vector, um, uh, the vector stuff, then I could really do some really cool stuff with 3D. But for now, in software, you can still do it. So you can still have, like, I don't know, your kung fu master knight, right? Like judo chop, right? The other piece in 3D, like a clip from the S3. So things like that. I mean, not a lot of people would think of things like that, but I'm just telling you that these things are possible. And this is proof right here. We're doing 16-bit. We're doing 16-bit 3D animation in real time, streaming it, and we could be multicast. Yeah, it's slow frame rates and all that because it's not optimized and it's in the early days. But I'm just trying to tell you, where we can go. And I think Project Blue for young people, kids and stuff, could be so much fun because they can learn how to use these boards. They can, first of all, they can afford it, right? It's less than a cup of coffee and ice cream, and all they have to do is, like, press a button, it'll load the OS onto the board, and then, with a mouse and, keyboard from their computer, from their laptop, or from their device, they can interact with the desktop and do programming without programming. Now, if you want to do programming, obviously it'll have two modes, right? For like buttons and timers and windows and functions. So it'll have the basic mode, which doesn't require any programming whatsoever, and it'll have the advanced mode where you can actually put C code and like Arduino code in there. And it's not Arduino code, C code. And then basically you'll be able to, execute that. So that's really where I envision going. And this is just a hobby, right? This is not a product for sale, and this is not to make money. This is just hobby stuff. The stuff people do for fun, and if other people like it, they can use it if they want. That's all it is. It's not for profit. But I hope you like this, and it makes me a little bit nostalgic, seeing the Amiga ball again. It's too bad it's not bouncing, but we can do that too. But this is all I want to show you for this piece. And Kung Fu chess. Yeah, I'd like to do that. I think that would be fun. Okay, see you in the next clip. Clear that. Nope.